want to talk to you about some very special functions. Functions where the domain, in fact, represents the natural numbers. So the only allowable inputs are going to be 1, 2, 3, 4, 5, 6, and so forth. In that case, we can actually list the function by just listing the y values. The y value associated with 1, then with 2, then with 3, and so forth. So you can make a list. And in fact, those lists are called sequences. So sequences are actually very special examples of functions where the input, the domain, is actually the natural numbers. So there are lots of different types of sequences, but a really famous type of sequence is known as arithmetic sequences. So arithmetic sequences, they're sequences where when you look at the list of numbers, you actually see a pattern. That to get from one number to the very next one, you just add a particular amount, and to get to the one after that, you add the same amount. In particular, we see that consecutive terms in an arithmetic sequence will have a common difference. If you subtract one from the other, you always see the same number. Let's take a look at some examples, and let's determine whether each sequence appears to be an arithmetic sequence, and if so, let's find that common difference, and then let's find a few more terms. So here's our first function, if you will, or now think of it as a sequence, a list. And so it's 30, 25, 20, 15, and so forth. And let's see if we have a common difference. Let's take the difference, this minus that, and see if it's always the same between this minus that. Well, 25 minus 30 is negative 5. Okay? Let's see if that's the same difference as 20 minus 25. Well, 20 minus 25, negative 5. Common difference. 15 minus 20, negative 5. So I do see a common difference. It seems to be negative 5. If that pattern were to continue, then I would say this does look like an arithmetic progression, because that's what's required of a progression, of a sequence rather, to be an arithmetic sequence. It has to actually form this common difference. So if we have this arithmetic sequence, what would be the next few terms? We can predict them. This is what we've seen before. Once we see the pattern, we can make predictions. So the next few terms would be, well, what would you do? Well, we see the pattern. We start with 30 in this arithmetic sequence, and we subtract 5, we get 25. Subtract 5, we get 20. Subtract 5, we get 15. Subtract 5, we get 10. Subtract 5, we get 5. Subtract 5, we get 0. So the next three terms I would predict would be 10, 5, and 0, if in fact this sequence really is an arithmetic sequence. Let's try another one together. So here, the sequence begins 4, 7, 11, 16. Let's take a look at the differences and see if we have a common difference. The difference here is going to be 7 minus 4, which is 3. That's fine. Now the difference here, 11 minus 7, that's 4. Already I see we don't have a common difference. We can stop here, but just for fun, let's just look at this difference right here. We see this difference actually, 16 minus 11 is 5, so no common difference. That means not an arithmetic sequence. So this particular sequence is not an arithmetic sequence.